After all, light cannot just stand still. It cannot even slow down.
Hi, welcome to my channel. If you know, this is about light. The light is electricity, the light is energy. Even in the public domain of physics, there is wrong. They are saying that light, it is a wave, electromagnetic wave, and has different kinds of frequencies. Visible light is from here to here, if you know, and that's why. So the electricity, basically, they are saying somehow is a phenomenon of light. There are many things that go with the speed of light, and I'm telling you that the light, so energy in general, like electromagnetic waves, and what they are saying, infrared, ultraviolets, and things like this. And you only can see a small range of. I'm telling you that light is not a frequency. But if you know, I cut from other videos and about the speed of light. You see, you can from this. This guy, my first video on this list is my third video on light. You see the channel of this guy, and you can see this video. So watch.
One clock will be running faster than the second one from the very beginning, by such a value that when we finally measure the speed of light, it will turn out to be exactly what we know it to be. Almost 300,000 kilometers a second, even though this may not actually be the case. This is how you can dodge and come up with method after method ad infinitum. Actually, scientists have been doing this for 100 years. They haven't come up with anything. It turns out that we are at a dead end. To measure the speed of light in one direction, we need to synchronize the timers. But in order to synchronize them, you need to know the speed of light in one direction. We return again to the fact that in the physical world there seems to be nothing more elusive than light. Not only elusive, but also irresistible.
So if you watch that, I will insert passages from here to say that this is what they are saying. But if you listen them closely, they will deny what they are saying. And so they say they calculate the speed of light, but it isn't. But it will calculate it, but it isn't. You see, in an example like this, he is saying the speed of light through the glass to water and through other medium says difference. Look.
Not at all. Now we'll respond to the argument that the speed of light is only maximal in a vacuum and drops in other media. Indeed, this is the speed of light in water, and this lower value is in glass. This might sound amusing, but enthusiasts even calculated the speed of light in sugar. Here it is.
So now they are saying somehow in a vacuum space the speed of light has some value, and but you see, but when this slows down, but I'm telling you that they not measure even this, and the light does not have any certain speed, and I'm telling you, you burn this paper, you release light from it, does not have any speed in this paper. Okay, but if I told you that they are saying that the electromagnetic spectrum is like this, you see, like these bigs, and then faster and faster and near one to another, and they say this is a visible spectrum like this. This is the colors, you see. So that's why I'm telling you the light is not a vibration, a frequency. You imagine what's the point in the all manner type, like when you film you see they will do this with frames. Like you make a picture and another picture and another picture and another picture and another picture. How many you could per second, you see? So between 30 and 100 per second, you have a good movie. Even if you put 30 frames per second. So 30 pictures per second with me in a row like this, and on a film you see like in a tape like this, and 30 pictures per per second. So you open and close the apparatus where you are filming. You have a substance like this paper, like here, okay, a lentil, and somebody invented it. So do not let yourself trick by this technology stuff. The technology was invented. A guy from America invented a TV. Many did this, but one single guy is identified, like Wright brothers on flight. But they do the bicycles, the aeroplane, the plane, the jet engines. The Romanian says there is a guy from Romania invented this. Some Canadian one guy says it in South America. But the Americans, more publicity, they invented. But you understand, when this idea taking place, many guys work on this. So now the Edison invented the light bulb. I'm telling you, they illuminated already a big chamber in 1700s, 1800s. They knew how to produce some electricity. The electricity was known in 1600. And 1601, guy Otto von something made the fourth electrostatic motor. So how do you are making films with frames like this? You photocopy me, you see, you put a lentil like this, and you see the apparatus filming. So you open and close, open and close, and open and close, and you make many pictures. You put, if you discover that you put 30 pictures in a row like this, making fast, you make a movie. You see me move, okay? But not this like this. You do not see one if I put 30. This you see, you perceive time in a few measures like this. Time is like this note. If you know in music, like this note, I'm telling you that the about time, okay, and this note, okay, and full note like this. These are the only times that we are working in music. This is sufficient somehow to represent all the times that exist. You do not understand other ones. They're with three brackets like this, also like this, and this is a measure of time with three like this, So if you understand this, I will explain to you how you will compose music. Because I'm telling you, the music is light, and the music is frequency like this. You saw that sound frequencies on your edit like this. The sound is a light manifesting like frequency, and does not have a speed. How you are saying, the wave of propagation has a speed, and this is wrong also, because you see, you say that it is the medium oxygen. You do not know that it's fire. As fire is a separate matter, and things like this. But okay, but inside the wave of sound, like this vibration that traveling through this table, you see, is not traveling with the speed of sound, it's traveling sound also. But now if you understand, this is measures of time. This two of this is this, 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 and two of this is this. And this is maximum 1 second, let's say 1 second. This is 1 second, let's say full note, or 2 seconds maximum, like this. A big note, like 1, 2, 3, a big note. But you see, it doesn't matter. I teach you to compose music, but you see, it doesn't matter. I wrote it like this, but you, like being an artist, like you put a measure. How do you want? You see, this is a full note. This circle, empty circle. 1, 2, 3. But if you want, you could take it like 2. You sing the song in faster manner. 1, 2. This. But then you must keep somehow the proportion. You see, if you took this one like being this long, 1, 2, okay. Now, but this one must be half of it. This one must be half of it. So 1. You see, and the other one must be half of this one. You see, if you understand, and now you must because it's faster than a second. So you must perceive. We can perceive like in 1 second. You see, they're taking this like 1, 2, 3, 1, 2, 3, 1, 2, 3 in 1 second. So this is like a blink override. So we can perceive something shorter than this. So 1 2 3 1 2 3. You see. So now if you understand the four, you understand time maybe. That's why I explain to you music and how to compose music. So this is a big video how to compose music, and I explain to you music. But you understand time, this light, and okay. So if you understand now, it is sufficient somehow to free measures. If you want to do them, you can even do in an artistical manner, like this, with this and this, okay, and a full note like this. But it doesn't matter because we have 3 times, different times. And being an artist type like manner, you can interpret them a little bit bigger than not in a precision manner, like exact time. You see, when you sing with somebody, he must copy your frequency, your time, you see. But if you decide something, you hit the note in the same time, you finish it in the same time, you see. So with these three times, because there are times T1, T2, how long the note will take to be, okay. So you see, now you can vary, because you cannot obtain this always like a metronome, like exact, like a clock, pop 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 pop, like this. It will be like a machine. Maybe it's going to be ugly somehow, but even that, I believe even the computer does not do this. You pass light through it, and it varies the function, temporal function. When you press on keys, you send light through it, and it has register how big to be the measure, but it's all margins. So that's why this is you identify. First one, you see. A short one, fast on time, T1, T2, with it says fast. This was a Morse code also, okay? And a longer one, this point and line, only 2. That's a fast one, and you can vary based you fast. You see that the fast one and long. This is long. If you are stupid in a rhythm, you could make a Morse code to be like like this, point and line, if you know, point and line. But if you are stupid in rhythm until you obtain some measurement, you put a bigger fast, a long one like this, T1, T2, and everything that goes beyond this is a short one. Okay, so now you understand that this is the full scale of temporal things. If you train yourself to can put it, and there from 2 to 2 of these make this, 2 of these make this, 2 of these make this, 2 of these make 2 of these make this. But it is enough 3 of them. You see, it is enough 3 of them to make music. It's exactly like you must have at least 3 notes to have a rhythm, a note. And I believe that you cannot do that. And with 4, if you have 4 of one, is better. Okay. So now in a second is like 1 2 3, 1 2 3. And you can how you are saying 1 Mississippi, 2 Mississippi. This is a second. So you train yourself on a second. So I'm teaching you music. You understand how? But you see that this point is physics. Like you must understand physics and physics of light. So this is the first part to break see about light stuff. About light from this channel. Then I will speak about light. In the end, I will bring everything together, and I show to you the time is like Lego pieces, like this. Time is only like this, and you cannot break it somehow. So some function like this, and it's not a continuum. You are tricked somehow. It's defined only per second, per somehow like this. Okay. So watch another part about light, and I will speak. I will train to you how to obtain times and measurements, and how to write music. You see, I have a music book here to write music, unwritten music book, and I will explain to you how to read and to write music on notes, on classical notes like this. There's another way of putting it, like okay, like in a Greek manner, like Arab manner. But okay, so watch about light, and I'll explain to you how to compose music. Okay, even in my program, computer program.
All or almost of you have heard many times that one cannot surpass the speed of light. We'll come back to this vexing cosmic injustice later, but for now, let's remember that according to modern physics, space and time are inseparably linked. Like north and south, east and west. After all, the south cannot exist without the north, so time cannot exist without space in our world. Even more, it is essentially one entity, and this entity even has a simple and straightforward name: space-time. What does this connection and strange configuration imply? Well, some very amazing stuff.
Okay, teaching you how to write and compose music, like on old manner of time, like this. So, but I break up one idea. You see, this is a vibration. You see, it travels through the spring like this. But you see, when it goes some force or some energy, this is you imprime in it energy. It goes in and hits this another one like in a pound. You see, so it goes like this, but it comes it impacts itself. So now maybe you'll understand that it'll not go like only like a sinusoidal manner like this, you see. So you understand that it travels a force of quantity of energy, and the quantity of energy that you imprinted is not the only thing correct defined, because it's a tonality also, the note itself. In this case is mi. This is how it is defined. You can say it is do, you see. Doesn't matter, because this is do if you want, okay, if you understand. But this is how it was defined on the guitar. This is mi, la, re, sol, si, mi again. Yeah, 6 chords. This is how they were defined. And in a creaky manner, you accord them here and here, here and here, here and here, and then you jump. You put one like this, like in crooked manner. But if you will be correct, like to be all of them, like in this. But it defining like this in crooked, this is what I want. But if you will be correct to be all of them like this, so the accords will be another kind. Okay, but you now you understand what I told you the first time. If you go a little bit here and a little bit here, and you interrupt and give it again, and it reverberates and makes another kinds of wave, and you cannot predict how they are going to be, like the waves. Like you understand somehow that it's in a sinuous manner like this on the crest here, on the crest like this. There's do. And do is not a wave, it is a wave of propagating here. The do is a tone, is an impact of atom of light that makes copper with like a contact. You see, sound is not here, is not here, is not in there, is not here, is in a contact. But it's two flowers that hit themselves. The flower of the how they are saying, the atom of the copper, atom of the air, like this. And it implies the guitar also. The form of the guitar is a resonance. The box is multiplies inside this. It multiplies the sound. It multiplies exactly like a transistor. It multiplies the sound. If it is going to be the same like an electric guitar, and is multiplied indirectly exactly through some transistor like manner. It goes through a circuit and duplicates, multiplies in like exactly transistor manner. But now you do not receive an ondulation this in the microphone or in your ear. So the sound is not an ondulation. On this point, there's mi note in this case. Mi. You see, mi note. Mi. So even the sound itself is not a wave. I'm telling you. When it could be in this case is an ondulation like this on a guitar. On the piano is made like with springs like this, okay, and hit them with some hammers like this, static hammers. When you press that keys, okay, they hit the string that are fixed like this in a strong manner, and you accord them, okay. But in a flute you blow air, you see. So it's wrong. You are wrongly understand now that the flute and all the instruments create this. Are blowing type like instrument producing sound. What I'm telling you is could be that it's not a wave also. And even in a guitar is not a wave. The sound itself, because I see this electromagnetic waves. Light is not a wave. only in a specific manner. But now what you understand, you cannot define it, because when you travels like this in the spring will impact itself, and what it travels here is not only an energy, a quantity of energy, is the tone, the specific tone, and you do not know what it is. It's do. It's a do note. It travels through this spring, do note, mi note in this case. Mi note travels through this spring, mi note. So this is the tone, the frequency and the measurement. I already begin to tell you. So now the quality travels through this spring. Quality. This you cannot reduce everything to geometry. On the back of the horse there is a man. You cannot say that a man is horse. It travels on the back of the horse, but it's a man. What you are putting it, and it could be a man here, if you understand. On this way, it could be a man. Or if you understand that it has a face and subject object, that it knows the object as some contact. This could be a face of a man here, and it's not a joke. Okay, so it's not a way, but now how you are representing in mathematical manner, you understand? It catches itself, it reverberates. So if I push the finger a little bit here, it will break the symmetry another time. So you understand now there is a mi note. There is not even a mi note, how you are defining. But you write it, but it is an artistic matter, it's not an equation, okay? It's not an equation. So it's some kind of tone, has some kind of frequency, some kind of vibration, and you cannot catch this. Because when I give it a second time, it ondulates like this and it makes a right angle, and then it makes like this, you see? But it's exactly the mi note. But when it catches it from, you see, so now you understand the sound. The sound is you cannot vary it somehow. This is decided by this guitar box, okay? And this guitar box produces a merging of sound, and this is another volume, okay? And so if you understand, even this is not only a wave like this. So you cannot put it in a mathematical time, because you cannot predict when it will do like this and when it will do like this. And on this vibration there you can define it somehow on vibration per seconds, and in another kind of there is different times vibration per second in a nose like this, a temporal nose I showed you before, okay? So now where is the do note exactly? You do not know where is the do note. It's a puntiform like manner. Okay, so I'm telling you that it is not a vibration even. You receive it on a vibration, but you receive a quality and a quantity, if you understand. So you receive a quality on temporal vibration. Okay, so this is the way I made the videos. And watch another part from this guy. I'm talking about light, but you do understand that it is not. I break up this idea. So watch another part, and I will speak more.
For example, how fast do you think a stationary object moves in space-time? Do you think the answer is zero speed? If this question seems stupid, take your time, because the actual answer might sound absurd. Any object moves in space-time at the speed of light, even motionless ones. This may come as a surprise to you, but there's nothing inherently paradoxical or even absurd to it. Because if you were paying attention, you'd notice that we're not talking about space, but about space-time. And any object with zero speed in space is actually still moving. It's just moving in time, always. It can't help but do this, because the so-called arrow of time always inexorably points forward, and it always moves at the speed of light. But in time, not in space. This sounds somewhat nonsensical, like 1 second per second. It's like saying I walk 1 mile per mile. But essentially, that's exactly how it is. Yes, from a physical point of view, this is indeed a movement no matter how hard it might be to comprehend. By the way, have you ever found it strange that we use the same words for positions in time as we do for positions in space? Back to the past. Look into the future. Time flies, etc. Think about this in your spare time.
Okay, I break up this idea from digital stream and a normal stream. You make a picture with me here and another one like when I'm moving. Okay, 30 per second is enough to produce movement. And now you pass them to a reading diode emits light and it reads the pictures. Okay, and you transmit it. This is a frequency. What's the frequency? 30 pictures per second, 30 frames per second. So it isn't some kind like a frequency like here. You see, like. So this is a picture, this is a picture, this is a picture, and you receive it with a frequency, 30 per second. In continuum stream or digital stream, you do not receive them like this. You put it through glass like this, okay, and you inject exactly the stream. So now you are wrongly understand that you are the light is a wave. Is that what is going to be the point to transmit in wave manner like this? What would you transmit? A temporal stream, continuous stream, or exact duplicate of me. So the light in this manner is not a frequency like this. How they are saying. So this, you understand that they are speaking like a populist manner. A frequency faster in nanometers and big wave, radio waves are 1 meter. So what was going to be the point if I'm speaking on a radio like in short manner like this too long my wave of speaking in 1 meter radio wave? Where is going to be the point? It's imbecile manner. It's like the resonance box where you distribute short waves like this of sound. But the sound is not only on a wave only. It has some kind of quality pictures like do, mi, even. So you understand. So in no matter is it. Why does this matter? Because it's not with geometry. You do not reduce it of geometry. So in this manner I show to you how to compose music, okay? So now you understand the frames per second, digital and second. So it's better to have 100 pictures, you better quality of. If you transmit in all manner like you see, you put on the tape small pictures like this. You see there it makes zoom already in video tape player cassettes like this. The me is like the here is let's say 0.5 meter, okay, and you put this like here. So it's already a zoom. So when you project light through it goes in a piece. You read it with a reading diode, and it transmits it in with a light bulb, exactly like this. The lamp of a television was invented in 1900s by a guy from America. I've told you already. So many people revendicated this. Okay, so if you understand or not, you have instead of this paper a screen, and the screen is capable to receive light. It is okay, that substance, black substance, expects to shoot it in light. And with what you do, you shoot light with a bulb, light bulb. So instead you have a light bulb to illuminate yourself. You shoot pictures like this in frames per second through the light bulb. You shoot them instead you to project them. You see, like there was a Charlie Chaplin movie like this. You project light through it and projecting on the wall. And the guy thought, what will be to not projecting on the wall and do not be like in a tape to transmit into the cable. So now you understand, you not transmit through the cable wave like this. You transmit exact pictures in the whole manner. You transmit it on a frequency 30 frame per second. Only in this manner was a frequency of pictures, but what it was in the picture was a defined picture, temporal picture like this, where with a small you can put it in a cable like this. So now they realize that the small of the picture, the zoom of the picture can be made small. So you can put this big picture in like this. So you transmit now many like you are doing this, okay, like you are doing this. You transmit many per second. But you do not need now this, realizing that you can duplicate in a continuum stream. This is digital manner and a frame like type manner. So it is not a wave even in the first place. It's already a frequency because you send real pictures in the frequency. So you understand that visible light is not like this, is not like this. If you understand this. So these guys I'm telling you all the science is wrong. Okay, so watch another part from this guy. He speaks about light and the speed of light. I'm telling you the light does not have any speed. And okay, in this you pull out from the battery light and goes in the light bulb like this. And it is in the battery light, electricity is light. But you deny this because you accept craziness from that, but they do not teach you anything. So now let me teach you how to compose music, okay? So but watch another part and I show you how to write music song. But you see that is important for the time. What is time in life? So and the transmission, radio transmission and live television transmission, I explain to you how it is done. So watch.
Well, let's move on. How does this benefit our understanding? Look at the map of the world. We can determine a location on a map in terms of two numbers, latitude and longitude. With space-time, it's almost the same. We all move forward through time or space, just as a traveller moves east, west or north, south. To make this easy to understand, let's imagine that you're in a large flat area, for example, in the Bonneville Salt Flats in Utah, where racers gather every year. You're getting into a car with a locked accelerator, so it can only travel at one speed, 100 kilometers an hour. This will be our conditional model of the speed of light limitation. We'll show everything that happens from above and present in a chart. The x-axis shows the way to the east, and the y-axis the way to the north. You start the engine and drive off. If you drive strictly east for 60 miles per hour, you're not moving at all in the north-south direction. Similarly, you could drive north at the same speed, but then you would not be moving east or west at all. And if you drive northeast at 60 miles an hour, you'll be moving partly north and partly east, and your speed would be distributed between these directions. Accelerating towards the north, you automatically slow down towards the east and vice versa. Finally, if you drive north at maximum speed, your eastward speed becomes 0 and vice versa.
So if you watch another part, it's important what the guy says also, because I'm commenting if you watch carefully what he's saying, okay? But I'm telling you that it is not what is going to be the point to tell you the same thing. Light has a speed, different troubles, makes Einstein interdict EMC waves disperse. So what is going to be the point? But it's a false physics, okay? Energy, but I explain to you this. I'm explaining to you that Einstein was wrong, and it travels in energy. Light is not energy. Travel. Okay. So you see this how to compose and write music in this. The third video on light, and you learn how to compose music. And I'll show to you maybe in this video another video in a program, computer program. So I'll translate this in a computer program. Okay. So now they decided to have 5 lines. This is music, but you cannot see them. Okay. But they decided to have 5 lines like this. But the notes are do, re, mi, fa, sol, la, si, do. 8 notes. But it's enough, like in their mind was enough to put 5 lines. This is how they decided, this is what we're doing, okay? 5 lines like this, okay? So now you have do, re, mi, fa, sol, la, si, do. This is the temporal description I've already showed you before like this. It is so manner it is enough 3 times. A short one, a bigger one, and a bigger one. It's enough because you not give this no. You'll give a what I did not show to you because a variation, temporal variation. Or a professional, maybe you will understand this. You put them with points like this. If you saw them from earlier, okay, you put a point, it means that it has this note and another, this is time, this is time of a note. It's a mi, very easy, it's a mi, do, re, mi, fa, sol, la, si, do note, but this is a measure of time. So if you put a point like this, it means that this note has, this point has this note. okay, temporal time is not a double, is between this and this one. So but now if you interpret like it's enough 3 measurements, you see, 3 measurements, and you go a little bit bigger than the short temporal node, and you can put points like this also, and a little bit bigger than this, a little bit bigger, say you vary 3 temporal positions, a short one, a bigger one, and a bigger one, but it's time, this is time, okay. So in this manner you represent time, and you have do, re, mi, fa, sol, la, si, do, okay, and you put them on the scale, if you know, on the scale. So now again you are wrong, that is somehow this is above, this is under, this is what I decided, this is not under the tone of this one, and this this is tricks. This is tricks to compare somehow, like the energy you can go and trick yourself with this. So now they decided that this line, second line is sol line. So you mark it with this. See, you know that it is sol. But to have some to know that it is sol. So if you put here, it is a sol note. You see, so this is a point is a sol note, and now you put temporal, you put it temporal like this, okay, and now this is sol, okay, so this is sol. So now you understand that do is under like this. You take another supplementary line, do, re, mi, fa, sol, la, si, do, okay, this is a scale, do, re, mi, fa, sol, la, si, do, okay, like this, do, re, mi, fa, sol, la, si, do, and this does not matter, this is, and they give, make another scale with fa, no, taking a fa under this, you see, you take two scales, all the instruments you have four fingers, so they decided to put it in a classical manner because you only operate 4 fingers. With this one you take the instrument. So in the classical manner, the violin, viola, the violoncello has only 4 chords, and enough. So there is 4 scales somehow of do scales. But you must say what is the scale. If you take 4 chords like this, you see, from tone to tone, and okay. So now this is me. This decided that is me. Okay. Okay, so you follow here, okay, and you make like let's say mi 2 times, do, re, mi, fa, sol. So these are 2 shorter ones. So this is on time. Okay, so now how do you notate this? You see 2 mi like this. Okay, you put two notes like this on mi no. Okay, so you decide the measure now. Let's say this is a full note, like a full note like this, mi like this. But you decide, maybe you want to represent them with this, like this. But it doesn't matter because you decide this, mi. You see, like this. But you know that the measurement, because the music is not like some conductors on a philharmonic decide to be faster somehow. But so they put a point like this, and it is stupid somehow to retain the same. It's changing somehow structures, but so you decide if this is like this one or this big. You decide, and you put 2 of them. It's 2 of them. But you see, the second one is longer, short and long. So now you must treat the measures. You see, you put one short like this, and you put one double like this. So me, but like this, you see. But if you put it, if you decided to put it like this, like a full note, somehow you put a second one with empty, with empty, like this is a double note, like with a double note, like this. With empty this, okay. So but you decide how to know. You can believe in your head that is the first one is like this, short, okay, and the second one is like this kind, okay. So you decide, and you put in here on the on this, okay. So now you have how to put many instruments. I will not draw the lines again, but you imagine that they are like an indicator somehow. You see the first under the first line is do, under the first line immediately there's re, on the first line there's mi, la, okay. So if you go from here to here, there is a bigger scale like this from here, like this is a scale do re mi, and you can go farther above like this, above, like above, okay. But now if you take the flute, you see there is another, you are tricking yourself somehow, but is the accord is in the tonality, so it is not the same though. If you imagine, like if you put this note with this chord, they will vibrate in the same time, in a frequency per second, but the tonality somehow differs, because this is a thicker one, this is less thicker one. But then the do of the flute has some kind of similar frequency, some kind of, this why it is do note, you see. So now you can treat the and you say what is the instrument, flute at the beginning, for the part for the flute, and has 4 scales, the instruments, and 4 scales, you know this. So a scale is here, and one okay, and you can put a fa another line like this. You know that there is the other 2 scales on the scales, and what you have left you put it above, and so you put 2 rows like this, and you put you have 4 scales, like 4 chords, 1 scale, the second one, the third scale, the 4 scales, do, re, so each one has do, re, mi, fa, sol, la, si, do, re, mi, fa, sol, la, si, do, re, mi, fa, sol, la, si, do, a higher one in pitch, but now they define it as mi, like, and this is, so this is some wrong stuff, okay, but this mess you up, but okay, but so let's say this is mi scale, la scale, so mi, la, re scale, si, mi. You see, so you have the mi scale, mi from mi to mi, la scale from la to la, and okay. And now you must want to write for 2 instruments. Let's say for guitar and piano. You see, so now you define some measurements, from here to here. From here to here, you decide to put only 8 notes, 8 notes, like this, 8 notes, and only 8 notes, like full notes, like this kind of, like this kind. So I'm teaching you music, if you understand. I'm composing music, and I'll go and teach you on the my computer program. But you understand, for you to understand time, the real trick in yourself, and you cannot correlate time with space, like Einstein said, you cannot. The time is a different kind of stuff, and if I told you that the light does not have time, so you cannot correlate the time with space, like Einstein said. But you will understand only like this to enlarge your conceptual thinking about time. So only in this manner, understanding music somehow, and how the measure in music is made, you will understand this. That's why I explained to you frame per second, how they will transmit, because it basically it's about light. And okay, so now you have this note, okay, and you decide in this interval you put only 8 this. So this is a temporal measure. only a this kind of things and an interval like this, a notes like that. But you can break this in two like this, in two like this. We'll make a note, okay? So it's some mathematics involved. This plus one, this plus this equals this in temporal. So now it is a note like this, but there's 16 notes like this, and there's 32 notes like smaller one like this, and you put it the 4 notes, only 4 notes like this and 2 like this in this interval, okay, in this interval that you decided to put only a notes. So now you write for 2 instruments, so this is flute, let's say flute and guitar. Okay, flute and guitar. Keep in mind that it is basically has a 4 scale, the flute, and all the classical instruments this has 6 scales because they decided no instrument they have 6 scales, like a bigger cello, like because they wanted to cover when it goes somebody to sing even the down notes, okay, they put 6 chords, and they have the higher pitch also, they put 6 chords, but a classical cello has only 4, and that one was like you take it and you can sing bigger things, okay, and only one instrument with 2 of them. So you have flute, you basically have 4 basic scales. A professional flute, if you all the instruments, some higher they have a tube like this when you blow wind on them, but maybe it's only 2, how professional it is, maybe it's only 2 scales, like this, like you have 2 chords like this, so you only have a down do re mi fa sol la si do, and higher one do re mi fa sol la si do, only 2 scales, like some blowing wind instruments that small like this, and maybe you have only but if they decided they make 4 scales, and the piano have 10 scales, 20, it depends on what okay, and a small okay, so now you must put them together. If you see, you put 8 notes on the guitar like this, 8 notes, 1, that's 3, and again 2, that's 6, and then you represent the time of them, you see, and put a note on the, okay. So for the simplification, let's say the guitar give only 8 notes like this, full notes, like this, only 2 by 2, let's say 2 by 2, like this. 2, 2, 2, 2, and but I did not manage to border myself in a correct manner. But I should have finished it on that brackets. I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. 8 notes like this. You see. 2, 2, 2, 2, you see, and you must finish it here, because you must put them in the same temporal manner with the flute. So let me draw another one, and it's not a matter this it's the music, but you see better here because you do not see the lines. Nonetheless, so watch another part of Lightroom. This guy, I'll continue to explain to you how to write and read music.
Now replace the word north with time and east with space in this thought experiment. Please look at the diagram. If you move through space at a maximum speed, the speed of light, then you won't move through time at all. It would kind of stop you. And even after moving over vast distances of billions of light years, you won't feel the passage of time. This would feel like one moment for you. On the other hand, there's no way for you to stand still, because time moves inexorably forward. In fact, it turns out that everything in the space-time always moves at the speed of light. It's just that one part of this speed falls on the north, time, and the other part on the east, space. That is, you're never simply standing still in space-time. You move either at some speed in space or in time. If the speed in space increases, then the speed in time decreases, and vice versa. Like in this diagram where the vertical represents the speed of time and the horizontal is the speed in space. Take a look here. When we increase the speed in space, time slows down. When we decrease the speed in space, time speeds up. That's how the space-time continuum works in simple terms. To complete the picture, let's look at all these amazing effects through the eyes of the person who figured them out. For a moment, imagine yourself as Einstein. While still a young clerk at a patent office in Bern, Switzerland, Albert Einstein had a sudden insight. One evening in May 1905, he heard the chimes of this old clock tower. All of a sudden, he was struck by a wild idea. What if the tram rushed away from the tower at the speed of light? And then he realized that if he looked back, he would see the tower clock had stopped, along with everything else: pedestrians, birds in flight, raindrops. This is because we see everything only thanks to the light that reaches our eyes. And if we were to move at the speed of light, then new reflected beams of light simply wouldn't be able to catch up with us, and we would only see that last frozen time. Note that the light would continue to move at the same speed, though it seems as if everything has frozen, even the light itself.
So now you see this is the measurement, 8 notes, and this is for flute, F, let's know flute, and guitar with G, okay? So this is for flute and this is for you understand time in this manner. If you watch careful and you want try to understand, because everybody hears music and you understand music, okay? So this is flute and this is guitar and this is an interval of 8 notes. So now you must synchronize them. If you want to the guitar gives me. You put me, okay, mi note, full mi note, mi, okay, like this. In the same time when it begins, the guitar begins to give mi note, the flute gives do note. So an accord, different note, okay, so do. So, but in the same time, do. You see, so if I make like with these full notes, like for you to understand better. This is the first note, 1. I said it must be 8 notes. And then the second time the guitar gives do note. This is do, okay, and the flute gives mi, like in reverse, mi. But at the same time, mi note, okay. But now you can make some stuff. You put a pause to the flute. Pose to the flute like this, okay, like this. So representation of a pose like this, and different representation of poses. Each measurement of time has a picture of pose, like to measure a pose. If the note is like this, a pose that does not contain sound that length, and there's different representation of them. Like this is for this. And another kind of poses, okay. So the third note is missing for the flute, and it has only the guitar has the third note. That it is mi again. So see, mi do mi. This is but when so this is together, mi with do with me. And this is me only on guitar, but the flute does not have it, okay? So in a fourth note, the guitar makes pose like this, and the flute gives mi note, like this, okay? So this is in the same time mi do, mi pose on flute, and flute and pose on guitar like this, you see. But if you understand now, you can vary even the measure. You see, you put a full note here, do note. But you don't know. But you want to fill this with two rapid ones on flute. So this measure you put do like do, but in a measure like 1 plus this one equals this one. So when on the time on the guitar gives do no like this, 2 of these are given by the flute. Let's say there is a do note. You see only 2 notes, do. only with two notes. You see, do mi, pause mi, do do do, and mi do mi, pause do. You see, and you can do this in reverse. The guitar gives two smaller temporal notes like this, like mi notes. Let's say mi like this, rapid ones, and the flute a big note to encompass them, like this. Okay, and you have 1, 2, 3, 4. You can count the poses. That's 4, 5, 6 with this, because you count it like a one note, like this. Like 1 plus 1 is 6, and 2 more, and you break the interval. As you say, you put all 8 notes in this interval. 8 notes. You see, they are not 8 notes, 8 notes like this, but you see, if you count it 1, 2, 3, this is 4, 5, 6, 7. You see, but you define it 8 notes like this. So you put two faster ones like this. So you can put at the end 4 faster like this, like this, if you know, and 4 of them like this. So with this, if you know the two of these, I show to you like in this manner, with two like this, made like this, and you can unite them on with like this. So instead of making them like this, you see, like this, 1, 2, 3, and how many do you want? You see, 3 of like this, you can unite them and put in like this, 1, 2, 3, and you make 2 lines like this, 2, and it represents 3 notes like this, like 3 in a row. You see, so now, if you understand, you put another line. There is going to be there faster ones. You see, you can unite 4 of them, and 1, 2, 3, 4. As I'm teaching you how to read, and like this, you see, 4 of them, and let me tell you, like I'm going to tell you again this idea. They do not have a function or a correct manner and resolve the equation with x of 5 power. And let me tell you this idea. If you find 5 variables with 5 substances different in music, you cannot put it on numbers, and you have this in music, and you cannot put it on numbers. So you cannot make combination or everything, because there exists not solution for x of the 5 power, and I believe for 4 power. And this means that you have 5 groups, so 1 to infinite, 1 to infinite, 1 to infinite, to represent different quantities, like qualities. 5 rows like this, 1 to infinite, 1 to infinite, 1, 2, 3. This is so hard, by the way. 1, 2, 3, 4, 5. Okay, and infinity. 5 rows of numbers like this until infinite. If you have 5 rows of infinite, you cannot intersect it in correct manner. Mathematics, they did not discover the solution. So if you have 4 substances, you cannot make them in a quantity manner. So if you have 4 substances in qualitative manner, you cannot intersect them in mathematics in correct manner. So you cannot put music on. And you have a few qualities. If you know do, the scale, the frequency, the poses, and other things like this. You see, this means that you go in continuous manner from a note to a note, another stuff like this. So this is the temporal, how you are writing. And now you can have many instruments. You see a violin, and you see this multiplies the combination, temporal combination. And if you understood from the first time, if you give this note the second time, you see, if you want to represent it like a sinusoidal wave like this in a geometrical manner, if I give it a second time, it reverberates, it cuts itself, and it's not interfering like the crest studies. It's not interfering like this. It could do right angles like this inside it. It you do right angles like this. Maybe you cannot see it in the vibration, but if you may translate them in light in the computer, you see the it makes even like this when you combine them. So if you give this one and catch it from the behind with this one, okay, in temporal manner, you cannot predict what we're going to do. This will interfere with this only if you make pause. And you make pause and wait and give another one, but you can give them one after another. This one catches the other one and changes the structure. If you in first manner ondulates like this, I can show you this on the computer to visualize the way. If in the first manner ondulate like this, you give the one, the second one it catches on the beyond. It lets it like this, and makes an accord of it. Both of them are interfering. He cuts the waves like this in right angles, and in there again both of them at once. You hear them both, and with different times, with different. So you cannot put even in this manner geometry. If you understand that this is the fourth note is like a vibration like this. So let's say this is a vibration like this, okay, and this is a full note like this. Let's say this is a full note, like I showed you before, like this, and me like this, a full note, A4, a full note, okay, and the second one is a La note like this, Mi, and La, full note like this, okay, a full note, and again you represent it like a sinusoidal manner, you see, but it differs the materials, different, so I put it twice, no, not this one, because this is thicker, this is less thicker. So the Mi note, I put it, I draw it double like this, in the double manner, more thicker, okay. Okay, you understand that I'm telling you that you cannot put math on light. You cannot put mathematics on music. You cannot put it, but if I do not explain it, it's somehow I'm crazy somehow. You cannot represent all this with geometry and numbers. You cannot. But if I'm telling you like this, you do not believe me. So then listen how much I know, okay? And I'll teach you in this process music, and I'll show you my computer program. This is a thicker wave. This is a thicker wave, and it's different material now. This is from flute, is different material. Like you have linen and you have wool or cotton. Okay, so different materials, different. You go intertext. The flute is different material. Like it gives you a different material. So, but this Mi note is thicker like this. La note is less thicker like this, but nonetheless, if you put them like this is La, and will vibrate this La like a wireless. This will vibrate this even though it's so they're both La notes, but different material. One is less thicker, one is thicker. So do both La notes exactly like this. So I told you this, if you put it here, vibrates wireless, this one. And so they both La notes, okay, but this is given of Mi's chord, and this is okay, whereas my, okay, and this is twice thicker than this, but now because is not twice thicker. So how we can represent this? This is 1.5 thicker. So, but what if this I put gold here instead? It's different material. I make one core from copper, one from aluminium, one for you see, if you understand. So this is La note. Let's say I write La note, but it's thicker, and this is less thicker. It has the same quantity of time, okay, and the same kind of ondulation how you represent it. But now let me tell you what is happening with them. If you give this first one, this second one, it catches in a temporal accord from the you see, because are they both? Look, I let it, and that one is comes later a little bit, intersects in the temporal manner. So in the first manner this is traveling by itself. Now the second one comes, makes an accord, this duplicate accord with the bows, but now they remain the same and they make a second note together like an accord, changing the structure of this vibration. So now you are hearing a combination of a fractal of wave like this. So it's unpredictable because you do not know how we will do this, like earlier as I showed you. So you give this, after half a time you give this one catches, you let them together, okay? So in the first manner you do not, but if you give them both or another, both time, you see, they will interfere for the beginning, they will create a resultant wave that will look different. So if you let this first and then you intersect in a temporal time in a second manner, they will interfere, will give you the different pattern, you will remain both separate, you will hear them both. They create another note in an accord, so different kind of interference, and but if you give them both at once from the beginning, they create another pattern for the beginning. Well, what I've told you is like, you give them like this. So now you representing on this, but you do not know, like a big composer even does not have a representation like this, and he tries to play the violin, you see, and he sees that if you go do note and re note, it sounds beautiful, you see, but if you making a structure, a continuous stream like this, do re mi fa sol la si do, okay, and then do re mi fa so you see the stream reverberates somehow. It's like you have a chord like this, a spring reverberates like this, but this time in the air. So you do not know the combination, how this changes the structure, but the composer discovers them. Discovers that in this string do re mi, if you pull la note, it reverberates in this changing structure, like in more kind of reverberation. So now you understand that the time is not in this manner, like this arrow in this manner. And if you understand this, I already showed to you this chord that vibrates in my previous video. You might see them intersected if you want like this, okay? You see it's static, and you send waves on it, okay? So now you see that it reverberates. What this means, it travels the quantity of energy here, so the temporal vector is like here, and then comes back like here. So now you understand that it restricts the arrow of time, because exactly in this manner, it travels from here to here and now reverberates, it comes back, and now it impacts like this energy between them. So what is the vector of time? But you see, when I sing this is breaks like this, okay? So now some part of it reverberates temporal. It has a temporal manner like this and a temporal manner like this. So now a piece that has two trajectories of time travels with a third trajectory of time towards you. But if you understand that Einstein is wrong, it's wrong. But now the wave, the mi note, what is the speed of note? Before I give it, what it is? What is the speed of the note? What is the measurement of the note? It does not have. And in the computer you can store these kind of pieces like this. I've showed you my program that I compose music, okay, and I teach you how to make music in that program in Fruity Loops. Okay, you see this, okay, if you understand, it can reverberate. So what is the function of time? It reverberates, made like this, and it is unpredictable because you do not know in simple manner that this crest hits this crest, and you see, and you must understand what it hits, because it remains in a constant manner. Some quantity of energy reverberates like this and goes like this, and you can understand like being two, like why only one? You see, it's here a quantity, here a quantity, here a quantity, and when this one goes towards here, another one goes towards here, another one goes towards here, and now imagine you have four on this chord, and you have, because you have atoms. You have atoms and the atom, I believe, that looks like this, or maybe like it look like this, or like flowers, more exactly, like flowers like this. So the atom of copper looks some similar like this in a geometrical pattern. You can identify with the flower that you in a geometrical type of manner. So now you understand, if you have four quantities of energy, if you put it do like this, you imagine that it travels one like this, comes back, and one like this and comes back. So now how you make a temporal vector of this? You cannot. It's music. So watch another part and I'll explain to you more.
But here we are talking about media that have what is called a light refraction index. If we send a laser beam through such a medium, light will interact with this material. Atoms of the material absorb photons of light and re-emit them. But when we pass light through a transparent medium, we don't slow down the photons. We are, roughly speaking, destroying them and then sending their descendants to continue their journey. This is just one very simplified interpretation of this phenomenon, because this process involves polarization effects and much more. But that is not the topic of our video. This is only one conclusion. Light cannot move slower than the speed of light, nor can it move faster. If you remove the matter and leave only an empty vacuum, then everything will go back to normal. You can neither slow down the light nor speed it up. No way at all. You wouldn't be able to fly faster than light too. And there are a number of reasons for this, which are as relentless as fate itself. As the speed increases, so does mass. And as you approach the speed of light, it grows exponentially and to infinity. Consequently, an infinite amount of energy is needed to reach the speed of light. You can burn all the stars of the universe in the furnace of such an engine, but you still won't be able to reach the speed of light, let alone surpass it. This is just one of the reasons. Another one is time dilation. And then there are violations of causality. You've probably heard all of this many times. There's one more example, but for some reason people rarely discuss it. If you decide to fly faster than the speed of light, you'll face another insurmountable problem. Electromagnetic interactions in your body also occur at the speed of light. It turns out that to move faster than the speed of light, you would have to move faster than yourself. This, of course, is an extremely illustrative example, but it's still close to how things actually are. So no, unfortunately, there is no way.
So now is my last part. You should understand, I'm telling you that you cannot put geometry and arithmetic on music. You cannot put it if you understand. So what I'm telling you this, you see, if now you treat me like an image, okay, you film me. There is a piece that captures me, like the ear is the ear that people do not know how it's functioning. Somebody discovered that you have this glass like put like this, like in lunar type like matter. You concave and convex, see, put them two, one with a smaller diameter to concentrate, like you concentrate lights, okay, and you have a material like this, and you inject me in that material not being like a chemical, being exactly like this manner, a strong material, okay, like even with copper layer and another layer and another layer, and this circuit increases circuits that it registers me. I will explain to you how these are functioning, how we will discover also, okay. So you imprint light on it like this, okay, in continuous stream. So now they are tricking yourself that you calculated the energy, the because you can pull it out from your computer and you can watch it. But and if I'm telling you that you cannot make mathematics and equation, you believe I'm crazy. But I've told you like this to understand how many ways of time you have and how many. So this is the video, my third video on light. I will make many in a row, and I continue to explain to you musics, okay, and I will watch what I did not say clearly to repeat some procedures of how compose and to I will teach you another way of writing music and how do you on guitar like. So if you understood, you cannot make it is unpredictable, and I will show to you how, a way how they are tricking you again, that you predictability. This is the word of science. The predictability, science predicts. You have T1, you predict T2. You cannot predict it sure manner, because I decide to put do, and I should ask you in a physical manner what will you follow from do. You see, I'll predict it will be red, and I'll give you me, just because I want to. Okay, this to not do like how do you are saying. Okay, so this is the first way of deny your will. Okay, but it is not like non. You not like A and non A, like in logic. I deny it like making your will. Putting me note. Okay, so this is their predictability, because you see the reality comports exactly like this. You see, you cannot predict the from T1 T2, because I go like this. Okay, I go like this, and you'll predict like on the second time I'll be with a meter, but in front. But if you say this, I go back with 1 meter on a right or okay, or right or left. Just to not make like this, you cannot predict, because the reality is made with light, and it composed like music. You see, it sings somehow with light. Okay, so it's not a coherent relation between do and re and mi and no. You cannot predict a string already if you have it in a composition like from T1 to T2, 4 minutes of music. Already you put the notes and you predict that it's going to be re, because you know the stream, how it will occur, how it is wrote. Okay, but you cannot predict it in another manner like this. And chemistry is like engineering type discoveries, and it's a way of simplifying the what will occur if you pour acid on something. On it. It's not predictive, it's not a temporal manner. If you pour acid on something, it gives you something. You see, so the predictability I close with this in science is wrong in this matter. I will repeat this idea. So, but I watch and see, and I multiply teach you music until I show you how to compose music in the program, and you repeat another way of how you write this. Okay, so this matter I teach you time. To understand that time is not related to space, you can store here, maybe I began this, but okay, so you can store here this way, and does not have any time. And when we copy, duplicate, and you can decide it to put more light from it, and you make longer time from it. But in the initial manner, it has only quantity of space. Somehow vibration is space, three-dimensional space. We believe in order to film three-dimensionally, you put a three-dimensional box, like small box, zoom, not like only. Okay, but even in old manner type, you can see three-dimensional somehow. It remains three-dimensionally. So this wave is a three-dimensional wave. You can represent it more bidimensional, but is beyond the geometry. And I'll show to you the waves of how they are looking more closely. The waves of sound, and you cannot make even mathematics on waves of sound or the light. So what is the speed of light? So this is the video for today. I will retake these passages from this guy, and second time I comment them further to prove to you that the time is not related to space. So Einstein false. To prove to you that in their equation there is sinus cosinus equation, and this disregard the waves that are made like this, and there are waves that are made like this, and you see there are patterns of geometrical patterns in this manner, like this in sound, like this, like you have the honeycombs like this in sound, and this is only a section like this, and is a tube, and it varies in length by time. Okay, if you understand, and you see that you cannot put the time relations on this one, and you understand that Einstein has a sinus cosinus functions in you can see square force relativity, but we have waves that are doing like this. Believe it or not, I show them in the computer, and there are waves that are not doing a sinusoidal manner, but like this in a right angles. Not right 90 degrees, like steep angles, okay, and obtuse angles like this. So in his he treats only sinus, cosinus, and formula. This is another type, and this is false. You see, but you can describe this kind of wave in the computer, and the light does this, okay, in right angles. So you understand that this is not a relation of energy, because energy travels in a square-like manner like this. It travels on the crest like this. So you understand that it's stupid physics, and you have energy in this crest like this, and it's right angles, and it has only sinus, cosinus functions, because he believes light is imbecile like this, okay. So but if I'm telling you that you cannot put mathematics on, so a mathematician now will observe what I'm telling you, and he'll be there to give me some crazy solution of this geometry. It is you cannot put mathematics on reality, geometry, numbers. You cannot. The equation will look like in chemistry, carbon, hydrogen plus, but it's not a plus for mathematics. You add them, you put them together like in the same sugar with coffee, and it gives you sweet coffee, okay? Like you put this, no, but it's no mathematical relation. It's not 1 plus 1, and it's not the geometry. The geometry tell you a little bit, and it's not this crazy, okay? This is the video for continue the idea, but if I'm telling you that the science is false, the mathematics itself is false. If it's inconsistent, logically inconsistent in itself. So you take geometry, arithmetic, algebra, this inconsistent itself is wrong, logically wrong inside it, and you put it on music, you be double captain breaking stuff. So I'm telling you that science is wrong. They are tricking you, right? Braille made the motors. Somebody invented the fridge. An American doctor was made the fridge, and they were working many guys to expand the gas. They were seeing the schooling. Okay, the electromotor was discovered. The electric clock was invented in 1800s. The electricity was known in 1600s. Auto, I'm telling you, the glass, everything what it is in front of you in a bigger city with the bigger towers, skyscrapers. So they are lying to you that they did it. The television was made, the transmission was made by an invention, and the plastic was an invention. The chemistry guys lied because they put some symbols, and they did it. It results from and it is an invention, a chemical invention, okay, plastify wood, okay, a way of plastifying fibers of cellulose, okay. Goodbye, God bless. I'm telling you that the science is wrong, and we can go to the stars. And what I'm telling you about light, because they are saying Doppler shift in nanometers in frequency, light is not a frequency. This is what is going to tell you they are crazy, if you understand. The light is not only music, it's not only frequency, if I told you, it's geometry. So now if you go with this further, the red becomes blue and the blue becomes red. Not because like donut. It's a donut, red is a donut, you cannot make from donut now. And they're changing between frequencies and qualities, and you are mess you up, and you do not understand it. So that's what I explained to you. Between me note and do note, and between frequency change thing with the do note, and in this manner you reduce a geometry, but there's no geometry. There's a real flower of a copper, like there's no made, is not made through geometry. This you back up somehow geometry gives you dough. There's not like this, okay? And you cannot do it through mathematical algebra only. So this is why I'm telling you light. They say that you go further. So if I mean like in an orange red manner dress and go, I become red. You believe this? So the star become red from distance. So now in nanometers, you see, if they measure some scales in nanometers frequency like this on a pace of vibration, they're identify this nanometer vibrations a billion years. So now you understand how crazy they are. So only though the vibration is a nanometer like this means a billion years because they want to. So they are tricking you. I'm telling you, this is a small star cloud. It's a cloud like you have clouds on the sky, and with luminous species inside our sphere you cannot see the universe. And this is close and you can reach here. But if I'm telling you this, you believe I'm crazy. So now I describe you all the frequency, the nodes, the geometry, the algebra, the mathematics. I'm telling you, I only wanted to say that this is our galaxy. Inside our galaxy, this is a cloud. Our galaxy is a sphere. It's not a spiral like this. It's a sphere. And this kind of galaxy are on the walls. You see, I'm looking towards that. Like you have a ball, and on the walls of the ball you have this, and there's a void, a semi-void, light void, and fire. There's many planets, and you can have here pieces, planets like this. Small rocks, you can unplug a star and put it in a pocket. There is not a relation between. I'm telling you, you can go to Jupiter to colonize, to make this, but you are saying I'm crazy. And you cannot put mathematics on science. This is a Pythagorean view, and I'll show to you how wrong it is. A squared plus c squared equals b squared, like in the sum of the cubes of the cathets equal the cube of the square of the hypotenuse. I will show you how crazy is this Pythagoras stuff. There are many areas with it, and you imply area. I'll show you all these things, but if you want. But if the stars are putting clouds, the clouds produce when they're not illuminating, not shine a light on a forest, you cannot see it. So, but that's missing. It's only black. Okay, and the stars are putting cloud. They can reach here. The stars are not making fusions, and the science is wrong. All of it. Quantum mechanics, Einstein, Maxwell, gravity of Newton. You can retain a little bit of force of impact and breaking point of classical mechanics, and this falls also because there are two kinetic energy treating with like Leibniz way who did it of doing it, and a force Newtonian, they are not identical for the mechanical movement. So that shows to you that even that is false. If I'm telling you like this, the Mendeleev is made with light. You put light, the sugar is like dissolves with the tonality of light in kind of musical type of kind, and you cannot deduce from this kind of solubility because it's like a flute note combined with guitar note, and you cannot deduce a song from a piano with a violin. You cannot deduce it from this, and you cannot make equations. And you are small children, trick like Pythagoras was trying to put numbers on before Christ 600 years. So 2600 years remain stupid, not wanting to understand philosophy and this kind of. And now small children that you put Einstein like being guru type, like being like you replace Jesus Christ like being the Son of God with this crazy guy Schrodinger, Heisenberg. They said nothing. And you like the technology like in gold manner type, like a Star Trek AG1 manner type, like the technology comes, you see that this is like a demonic way of doing it. The technology what you are filming with in a big technology, you have light bulbs in different manner, different colors in a town, you have transmission, television, internet, and this kind of thing was inventions, if you understand. Okay, goodbye, God bless. I explained to you more music, and I did or discompose the mathematics itself to show you that it's illogical and inconsistent. Okay, goodbye, God bless.